This is the third video, jumping to number 11. So, you want to get rid of the log. However, you need to isolate the log first before you get rid of it, right? Now, you might be thinking to apply properties, but the truth is, you have a -6 here. You could easily get rid of that -6 by adding 6. So, we're going to have a new equation. And now, after that, you might be thinking of the power property to move this 3 up here to be a power, but that would be crazy, that binomial to the power of 3. Why not get rid of the multiplication of 3 by dividing both sides by 3? That'll cancel out, that'll cancel out. You're going to have a nicer equation that says log base 5 of x squared plus 16 equals 2. Now, to get rid of that log base 5, you raise both sides to become powers of base 5, right there and right there. So this does cancel out. We have a new equation that says x squared plus 16 equals 5 squared. But we all know that 5 squared is 25, so I'm just going to write it as 25 instead of 5 squared. So we have this new equation. It's a quadratic equation. X squared plus 16 equals 25. Notice that there is no x, so I'm not going to set it equal to 0. I'm actually going to isolate the x squared because I could get rid of an x squared by square rooting. So I'm going to subtract 16 on both sides. I'm going to have a new equation that says x squared equals 9. Square root both sides. Your final answer is x equals, it should be plus or minus 3. However, you need to make sure that you don't have negatives inside your logarithms. And if we go back to the original, yes, it could be a positive 3 because 3 squared is 9. And it could even be a negative 3 because negative 3 squared is positive 9. Either way, you end up with a positive inside your logarithm. So both answers are essential, positive 3 and negative 3. Let's jump to number 12. On number 12, we are going to condense. Again, you don't want 2 logs on one side of the equal sign. You want it to be 1 log. So let's condense. We're going to take this log base 18 and that log base 18 and write it together as one single log base 18. And again, we're going to be using the product property because there's a plus sign right here. Now, product means multiply, so I need to take these binomials and multiply them together and write them right here as the inside of the log base 18. So I need to multiply n plus 3 times n minus 4. I'm zooming in and I'm going to show my work so I could write it right here with the log base 18. So when I go n times n, that's n squared. So I'm going to have an n squared. When I go n times negative 4, that's negative 4n. Let me just write that right here, negative 4n. And then 3 times n, that's positive 3n. When I combine the negative 4n with the negative 3n, I get negative 1n. And of course, 3 times negative 4 is negative 12. So that's the quadratic trinomial that I get when I multiply, when I'm applying the product property. So on the left side of the equation, I took this log base 18 and that log base 18, condensed it, multiplied these two binomials, got that quadratic trinomial. That's the left side of the equation. Here's my equal sign. Let me check out the right side. There's a 1 over there. A nice, beautiful 1. Okay, now at this point, I need to get rid of the log base 18. So I'm going to raise both sides of this equation to be powers of base 18. A big 18 right there, a big 18 right there. So these guys cancel out. I'm going to end up with the nice, beautiful equation, n squared minus 1n minus 12 equals 18. I mean, technically that's 18 to the 1 power, but that's still just 18. So since it's a quadratic equation, a quadratic trinomial equation, I want to set it equal to 0. That way I could maybe factor, split, and solve, or maybe use the quadratic formula. I'm going to subtract 18 on both sides. So I'm going to have a new equation that says n squared minus 1n minus 30 equals 0, of course. And now we're going to factor, split, and solve. The factored form of n squared minus 1n minus 30 is n minus 6 times n minus 5, or n plus 5. Now after this, you're going to have to split them and solve. So you're going to have n minus 6 equals 0. So it's crystal clear that we're going to have our two answers, n equals 6 and n equals negative 5. So all we need to do is double check and make sure those answers don't give us negative values inside logarithms of the original equation. So the negative 5 would not work because when you plug in negative 5 right here, negative 5 minus 4 is negative 9. That goes out the window because you can't have negative logarithms, or you can't have negative values inside the logarithms. So the only one that actually works is n equals 6. That's your only answer for number 12. Let's flip the paper over, jump to the back side. So on the back side, right here is where we have all these decimal answers. Notice the instructions say solve for the equation or inequality. If necessary, round to 4 decimal places. So you want to solve for r. Where's r at? It's in the exponent position. You don't want the r to be an exponent of base 6. So you want to get rid of that situation that has a base 6. So you're going to apply a log base 6 to both sides. So when you apply log base 6 to both sides, the log base 6 of 6 cancels out. The 4r comes down. That's the left side of your equation. And of course, the log base 6 of 28 is the right side of your equation. Now, at this point, all you need to do to get rid of the 4 in front of the r is to divide by 4. So you're going to divide by 4 and divide by 4. And your answer is r equals log base 6 of 28 over 4. Now, you can't leave that as an answer. You want it as a decimal, and your calculator really does all the work from here. If you have a Casio, you could just type this in right into the Casio, log base 6 of 28, hit the equal button, and then hit divided by 4, and that'll give you your final answer. Now, let's say you don't have the Casio. Then you're going to have to change the log base 6 of 28. You're going to have to work some magic right there. This log base 6 of 28, you're going to have to use a change of base formula so that your calculator could do it. Your calculator either does common log or natural log, ln. I want to go with the ln button. ln of the bigger number 28 divided by ln of the smaller number 6. Now keep in mind, when you're using your calculator, when you type in ln of 28, it's going to open up parentheses. You have to close the parentheses before dividing by ln, and it's going to open parentheses, and you got to close the parentheses, then you hit equal, okay? So if you have the TI, you don't have the Casio, you have to type this out, get that answer, it's going to be a decimal, and then once you get that decimal, then you're going to have to divide by 4, right? So that's the process. Whichever calculator you use, you should get the same answer. The Casio is just saving you one step, the step of changing it to a fraction with the change of base formula. Casio does that for you right here. So if you do either change of base formula, then divide by 4, or Casio and divide by 4, you should get the same answer. So there's your final answer. Notice that I wrote half of the decimal in black, the other in blue, because the instructions say 4 decimal places, 1, 2, 3, 4. Now you just need to make sure that the next number is not a 5, 6, 7, 8, or 9, because if it were 5, 6, 7, 8, or 9, you'd have to change this 9 to a 10, which means that'd be a 0, and this would become a 5. But because it's a 3, you could just leave it. So this is the answer that I want to see on your answer sheet. Let's move on to the next one. What kind of log are we going to apply to bring down that 9a? Log base 7. So we have log base 7 of 7. That cancels out. You're going to have a 9a is less than log base 7 of 22. Now don't be scared. You could actually do log base 7 of 22 with your Casio. So I get that long, irrational, nasty number. Log base 7 of 22 is 1.58848159 whatever. But I still need to divide by 9. Divide by 9. Ladies and gentlemen, just get your calculator. Since you already have that answer on the screen, just hit divided by 9, and you'll get your final answer of 0.17649. Let me write that down. Notice it says 4 decimal places, and if I look at my 4 decimal places, the next number is a 9, which means that should change the 4 to a 5. So this should be a 5 right here if I want to be on point. So A is less than 0.16765. So on number 15, we are going to apply a log base 3 on both sides to bring down the exponent. So on the left side, log base 3 of 3, that cancels out. The left side of your equation is going to be x plus 1 equals log base 3 of 27, or of 7 to the 2x minus 3 power. So there's my new equation. I've gotten rid of one log so far. I need to get rid of the other log, but the problem is that the exponent is still up here. The variable is still up there in the exponent position. So I'm going to use the power property to take this binomial 2x minus 3 and bring it down to the front. So I want to first put in parentheses, and then I want to take it and put it in the front as multiplication right in front of the log base 3 of 7. So there it is. I have x plus 1 on the left side equals 2x minus 3 times log base 3 of 7. This is no longer up there, so let me just scratch it out. So what we want to do is first find out what this number is. It's going to be an irrational number, right? So the log base 3 of 7, we could actually do that on the Casio, or if you don't have a Casio, you could actually do log base 3 of 7 with any calculator with the ln button or the log button. So you could technically change it to ln button of 7 divided by ln button of 3, and that will give you a crazy irrational decimal. Okay? If you have the Casio, you could type it right in, and log base 3 of 7, that'll give you an irrational decimal. So on the calculator, when I type in log base 3 of 7, I'll get this answer. Or even if I did ln of 7 divided by ln of 3, you'll still get that answer. Now keep in mind that that's a number that you still need to distribute into the 2x minus 3 that's inside the parentheses. So you need to distribute that crazy irrational number into the 2x and into the minus 3. And you still have the left side of this equation. So when I distribute it, when I go that irrational number times 2, I could just go to my calculator, since I have my answer on there, just hit times 2. And that'll give me a crazy decimal. And then if we were to distribute that irrational number times negative 3, we'd get a negative 5 point. You get that nasty irrational number. And of course on the left side of the equal sign, you still have the x plus 1. And if you wanted to solve this thing, you're going to move the x's to one side. So I am going to move this x, the x on the left, I'm going to move it over to the right by subtracting x, which is really subtracting 1x. So when I do 3.54248, all that nasty number, minus 1, it'll be a 2.542 with an x at the very end. Of course, we have the equal sign, and if we wanted to move this crazy decimal over to the other side, we'd have to add it. So if I add it to 1, it'll be that same number, but with a 6, positive 6. Keep in mind, you will be adding the 5.3 irrational number, so you'd be adding the 5.3 irrational number, so you'd get that irrational number on the left side, but with a 6 instead of a 5. So for my final step, I'm going to divide by this crazy irrational 2.5, whatever that junk is, and divide by 2.5, whatever that junk is. So on the calculator, you're actually going to type in the whole number. Divide by the whole number, that cancels out. Divide by the whole number, not just 2.5, but this whole number. And on the calculator, if you type in all that giant number, you get x equals 2.48328. And technically, on this section, they want 4 decimal places. So 1, 2, 3, 4. That 2 should be a 3 because the 8 changes the 2 to a 3. So this is your answer right here. 2.4833. So I do apologize. That one's a horrible problem. Hopefully it's nicer on the test. Let's take a look at number 16. Super quickly, I need to get x by itself on one side. I could easily get rid of the 6. That'll give me the new equation, 2e to the 6x power equals 18. I need to get rid of everything except the x. I need to get rid of that 2. I'm going to divide both sides by 2. And I'll have the new equation, e to the 6x equals 9. Now, I don't want my 6x to be an exponent. I need to bring it down. So I'm going to undo the base e with log base e. Log base e is really ln. So I'm going to do an ln to both sides. That'll cancel it out. I have 6x equals ln of 9. ln of 9 on a calculator is 2.197224577. The final step would be to divide by 6, and since you did this on the calculator, all you have to do is hit divided by 6, and you get your final answer of... Since it says round to 4 decimal places, this is your answer. Notice that the next digit over is 0, so it's not going to change a 2 to a 3. That's your final answer right there.